students. So good to see you once again back. Today I'll be taking the chapter Internal Forces of the Earth, that is folding and faulting. This is for class 9A, B and C, and I do hope that you have gone through your previous chapter, earthquakes, even volcanoes, though we don't have it now in the website, but still it was loaded earlier and because of some technical reasons that's not there. So please do whatever assignments I've given you in the previous chapters. Be serious with whatever you're doing. I know it gets quite hectic with this continuous bombardment of these online classes to you, but then that is the best we can do for you in these circumstances, and we do hope that you also make some effort from your side to study the chapters that have been given for the different lessons. And another thing is, please make sure that you are busy at home. When you are not studying, you can read some books I've been telling you. We also have some very important, nice and very interesting courses in the Facebooks. There are so many different courses for leadership management, how to train yourself to be an effective person, an effective speaker. So there may be some courses. So why don't you enroll yourself in these courses as well during this time and just try to experience yourself going through the different courses. I think it will be something interesting for you and it will be something different as well. So we have some, I've gone through some of the advertisements on the Facebook where they have advertised regarding different leadership qualities, the different speaking abilities, how to train yourself to be an effective person, and I thought that this would be very good for you. So when you're free, please do enroll yourself in these courses. In the first initial stage, it will be a free of cost course, so you can just go through it, and if you like it and if you think it's very good for you, you can also subscribe it, because I have also done one or two, and I think it's very good for you. So please do that as well. So coming back to the lesson, dear students, today we do the chapter that is folding and faulting. Now we know that the Earth's surface is constantly changing. The reason why it changes is because of two very important reasons. One is because of the internal force. It's also called as the endogenic force, the force that takes place inside the Earth's surface. Examples are volcano, earthquakes. See? These are some of the examples of the endogenic or internal force. Then we also have what is called as external force, which results to the change on the surface of the Earth. Though this change on the surface of the Earth is very gradual, we don't see the mountains all of a sudden changing into a plateau. We don't see a plateau all of a sudden turning into a plain. No, it takes thousands of years. It's a very slow process. The process of weathering and erosion. And these are because of the elements of the, elements like the wind, water, waves, ice, see the sunshine. These are the various factors which result to the change of the Earth's surface. So they are called as the external force. So let's go further and see. See, the surface of the Earth is constantly changing due to the internal or endogenic force and the external or exogenic force. Now we come to what is a plate tectonic. Before we come to what is plate tectonic, what is it? Plate tectonic is the theory of geology that has been developed to explain the large-scale movement of the Earth's lithosphere. So plate tectonic basically means the movement of the Earth's lithosphere. You know that below the continents and ocean floors, below the continents, at the bottom, we have huge slabs of rocks on which the continent rests. These are called as the plates. So these plates constantly move. And when these plates constantly move, it is at that time that gradually different features on the Earth's surface appear. See, that is the tectonic plates. See, it is the theory of geology that explains the large-scale movement of the Earth's lithosphere. Lithosphere is basically the rocks that are comprised, that basically makes the see mountains, plateaus, plains. See what we see on the Earth's surface, the lithosphere, the crust of the Earth, comprised of rocks, is called as the lithosphere. Now let's see the continental drift theory. Now we know that the continents did move and has been moving even, because of which the Earth has changed so much. If you see the picture of the Earth when it was first 600 million years ago, what the Earth looked like and what today the Earth looks is totally different. Completely different. Now what happened is because of the movement of the continents. That is called as the continental drift theory. Now it was first proposed by Alfred Wegener. In 1950, a German meteorologist and geophysicist gave his idea in this first edition of The Origin of Continents and Oceans. So Alfred Wegener had given the theory, had given this theory in his book, the first edition of his book, in The Origin of the Continents and Oceans. In that he had mentioned about this. He stated that the east coast of South America and the west coast of Africa were once attached. The east coast of South America and the west coast of Africa was attached. That's what he said. And he has said that because in studying the fossils that were found there, in studying the paleotopographical features, the climatological features, because of these features, he had said that at one point of time, the east coast of South America and the west coast of Africa was combined. They were one. That's what he said. But then many of the scientists did not approve this. The reason why they did not approve this is because they said that Alfred Wegener failed to prove the reason what caused the movement of these continents. Alfred Wegener failed to prove the movement what caused the continents to move about. He gave evidence with respect to the fossils and paleotopographical and climatological evidence to support his views. However, it was not taken seriously due to the lack of the evidence in respect to what really caused the movement of the continents. Alfred Wegener did say that the continents of South America and Africa was once upon a time together, and they moved apart because he gave evidence to prove the fossils, the climatological evidences, the paleotopographical features. But then it was not taken seriously because he failed to prove the reason why the continents moved apart. Okay. Now let's see. These are the plate tectonics. If you see the word, these are the different plates we have. Different plates are there. These are all the different plates. It's not that the earth is a solid. The earth is a solid, flat rock. No, there are different plates. Different rocks are there which are cracked. Which are joined in these places. These are called as the plate tectonics. And when these plate tectonics move, it is at that time that vibrations are created. And then that's what we feel on the earth's surface as earthquakes. Tsunamis are also created when these plate tectonics move. Okay, so these are the plate tectonics on which the continents rest. Okay, now let's see how the movements of the plate caused the formation of the present continent. How did the present continent come about? In the very, very ancient times, say 600 million years ago, there was just one big piece of land on the earth that is called as Rhodina. There was one big piece of land on the earth, only one big piece of land on the earth. That is called as Rhodina. And from this continent Rhodina, what happens? It resulted in the formation of 8 continents. 8 continents were formed. It slowly separated from each other. But again, these 8 continents again reassembled. They again reassembled because of the movement of the tectonic plates. They reassembled and they formed into what is called another supercontinent called as Pangaea. Which later broke up into Laurasia. Pangaea broke up into 2 land masses. One is called as Laurasia, that is North America and Europe, and the other one is called as Gondwana, which comprised of the other continents of the world. In the very beginning, Rhodina was formed. there was only one big piece of land on the earth called as Rhodina. When that separated, it formed into 8 continents. Again, these 8 continents reassembled because of the continuous movement of the plate tectonics, which resulted to the formation of a landmass called as Pangaea. This Pangaea broke up into 2 landmasses called as Laurasia, which comprised of North America and Europe, and Gondwana, which comprised of the other continents. The continent Pangaea was surrounded by a huge water mass called as Panthalassa. See? A huge landmass called as Panthalassa. Now, what was the reason behind the movement of these plates? Movements of these plates, or what was the reason behind the formation of these continents continuously? The reason for the movement of the continents was due to the difference in temperature in the astrosphere. See? The difference in the temperature in the astrosphere, which resulted in the formation of convection currents. That means inside the Earth's surface, as you go inside the Earth's surface, it gets hotter and hotter. So in this layer called as the astrosphere, because of the difference in temperature, what happens? Convection current was created. Pressure, force was created. See, force was created. And this force was the reason why, you know what happened? The continents were moved. See, convection currents were created because of the difference in the temperature, which resulted to the plate tectonics, or the plates constantly moving. Now you can see here, see how the continents moved. See, this is Pangaea. Before this was Rhodina, but this is Pangaea. See, it broke up into 2 landmasses called as Laurasia and Gondwana. And this was the sea, Panthalassa. Then from there slowly, see, the continents separated. And then they moved more apart. And today, see, we have what is it. See, they are completely separated. Now these are the plate tectonics. Plates are there. Inside the Earth's surface still we have plates like this. Plates are there, on which the continents and ocean rest. So this is how the continental drift theory move about. Now there are 3 types of plate movements. Now plate movements are basically 3 types. One is the transform boundaries, the other one is the divergent boundaries, and the other one is the convergent boundaries. What is a transform boundary? When the plates slide past each other along transform fault, the movement could be sinistral, left-sided to the observer, or dextral, right-sided to the observer. See? Transform boundaries. Okay, that means when the plate tectonics move this way, either this way or this way, horizontally, it is called as transform boundaries. This is the movement of the tectonic plates. When the plate tectonics move this way, it's called as transform boundaries. What is a divergent boundary? Occurs when 2 plates slide apart from each other. That means divergent boundaries occur when 2 plates, suppose these are the 2 plates. When these 2 plates move apart from each other, when they move apart, it's called as divergent boundaries. Transform boundaries are when they move this way, horizontally, sliding each past each other, grinding past each other this way, front and back. It's called as transform boundaries. Whereas divergent boundaries are when the plate tectonics move apart. When they move apart, it's called as divergent boundaries. Then we have the last one, that is convergent boundaries. What are convergent boundaries? Convergent boundaries are when a dense oceanic plate collides with a less dense continental plate. The oceanic plate is typically thrust underneath because of the greater buoyancy of the continental lithosphere, forming a subduction zone. See? Convergent. When they converge, what happens? One plate moves down this way. Because of the greater mass, they move down, and the other one moves up. That is called as convergent boundary. Coming towards each other. Because of the compression, because of the pressure, they are pushed towards each other. And when they are pushed towards each other continuously, the plate which is of greater weight, which has a greater, mass, which has a denser mass, which is more heavier, slides down, and the lighter one moves up. That is called as the convergent boundaries. You can see here. See, this is the divergent, convergent, and transform. So we have done the first one. What is the transform boundary? See this way. When the plates Horizontal movement, grind past each other. See what is going this side, what is coming this side. It's called as transform boundaries. See, lateral sliding. Lithosphere neither created nor destroyed. Nothing is created nor destroyed. No major effect. And here what happens? Volcanic activity. There's no volcanic activity here. This is a transform boundary. Then we did the second one, that is the divergent boundary. See, what is the divergent boundaries? When the plates move apart from each other. When the plates move apart from each other, it is called as a divergent boundary. You can see the diagram here. See, it's moving outwards. Spreading effects, oceanic lithospheres are created. Down, ridge and rift are created, and volcanic activity. Is there any volcanic activity here? Yes, volcanoes take place here. Then we have done the third one, that is the convergent boundary. Convergent means when they come towards each other because of compression, they come towards each other. See, and then the heavier one moves down, slides down. Here. Destructive, oceanic lithosphere destroyed, trenches are formed, and here also volcanic eruptions or activities do take place. This is the convergent boundaries. When the plates are pushed towards each other, the heavier plate goes down and the lighter one sinks up. That is called as the convergent boundary. Now, what is the driving force of plate motions? What really creates the plates to move about? So we told you that it's because of the convection current that's there. See, large scale convection. I told you the large scale convection current is one of the reasons why the plates constantly move. Currents in the upper mantle are transmitted through the asthenosphere. Motion is driven by friction between the asthenosphere and the lithosphere. Because of the difference in temperature mainly, convection current is created inside the Earth's interior, because of which the plates move. So that is one reason, large scale convection current. Second one is also because of the gravitational pull. See, plate motion is partly caused by the weight of cold and dense plates sinking in the mantle like trenches. The heavier plates, see, partly caused by the weight of the cold and dense plates sinking. The heavier plates move down, and when they move down, they exert pressure. And therefore what happens? It results in the formation of the movement, convection movements taking place inside the Earth's surface, which results to the creation of what is called as plate motion. Now let's go a little bit further and see folding and faulting. What is folding and what is faulting? The slow and steady change in the interiors of the Earth takes place due to the internal force known as the tectonic movements. I told you. Inside the Earth's surface, the Earth constantly moves because of the tectonic movements, which originates deep inside the Earth. The internal forces are of two types, sudden force and diastrophic force. So the internal forces are of two types. One is the sudden force, which takes all of a sudden. Another one is the diastrophic force, which takes very, very slowly. Now, which are the sudden forces? Earthquakes and volcanoes. Diastrophic means slowly. We have folds taking place. See? Folds and faults are caused by the diastrophic force, which are of two types. One is the vertical movements. It's called as epirogenic, and the other one is the horizontal movements, which is called as orogenic. So, see, two movements take place inside the Earth's surface. One is a sudden movement like earthquakes and volcanoes, and the other one is a diastrophic force like folds and faulting taking place inside the Earth's surface. Now, they are formed in two ways. One is the vertical movement up and down, and the other one is the horizontal movement front and back. So, these are the two movements or two types of movement that take place in the folds and fault. What is a vertical movement? We have 3 points here. Let's see. The vertical movements moving inside the Earth rises or uplifts a part of the Earth's crust in relation to the surrounding. That means because of this pressure inside the Earth's surface, when the interior of the Earth, inside the Earth's surface, what happens? When they are pushed up, when the rocks are pushed up, when a certain part of the rocks are pushed up, what happens? It moves up. That is what is called as a vertical movement. Other one, sometimes they depress or subside a part of the crust down in respect to the surrounding. Sometimes when the crust also moves down, because of the pressure, difference in pressure, because of difference in compression, Sometimes they may move up, and sometimes they may move down. See? That is called as the vertical movement. These movements are called as epidendric or continental building or plateau building movements. That means vertical movements are caused when, because of compression, sometimes the interior of the earth will rise up. That's one point. Sometimes again, because of compression, what happens? Some of the areas of the earth's surface, they will sink down. They move down. That is also an example of vertical movements. Now, what is a horizontal movement? See, the forces acting horizontally to the earth's surface cause the horizontal movement. The forces acting horizontally. What are they? These forces disturb the horizontal layers of the earth's crust to such an extent that they are beyond recognition. When they are pushed this way, because of such a great pressure, what happens? They look like, completely distorted. Very uneven surface of the earth will appear. When the very uneven surface of the earth appears, that is because of the compressional forces or because of the horizontal movement. See, these forces disturb the horizontal layers of the earth's crust to such an extent they are beyond recognition. They are not evenly placed. They are pressed so much that the land looks completely distorted. Very, very uneven. It's called as horizontal movement. See? Number 3, these movements are of two types, compressional force and tensional force. That means these are of two types, compressional force and tensional force. Tensional means to move apart. Compression means to press towards the center. It's called as compressional force. Tensional force means to move apart. Okay, so let's see. Compressional force. What is a compressional force? I told you what it is. When you apply pressure from the two sides towards the center, it is called as compressional force. Compression force acts from two opposite directions towards a common point horizontally, which leads to folding of the crustal rocks. Like this. See? Compressional force. That is, when you apply pressure, compression force, see, the land will rise up. Okay, tensional force. Tensional force, see. Tensional force acts from a common point in two opposite directions, causing the rock movements in opposite directions, that is, away from each other. That means when they are pulled away from each other. See, if these are two slabs of rocks, when pressure is taken outside this way, when they are pushed outwards, it is called as tensional force. And when these occur, what happens? We have the formation of rift valleys like this. Like this type of lines are formed. Because the land is pushed this way, what happens? This part will sink down. Rift valley is created. So these are the examples of a tensional force. Compressional force means a mountain will be created, hill will be created. Tensional force means a valley will be created. See, because they are pushed this side. When here when you push towards the center, mountain will form. When you pull apart, the land will sink down and form into a rift valley. That is a tensional force example, compressional force. Now let's see what is a folding. What is folding? When compressional force acts from two opposite directions towards a common point, the rocks are subjected to bend. These wave-like bends formed in the sedimentary rocks due to the compressional forces are called folds. Here. See, what was it formed? Compressional force. When the land is pushed, when the land is pushed, they rise up. That is the compressional force that's taking place here. We have anticlines and synclines being formed. See? Anticlines and synclines. This is because the compressional force pushing from the two opposite sides towards the center. Okay, let's see this. I hope you're getting what I'm saying. Please do pay attention. Don't get distracted. If you know that is the disadvantage of teaching in an online way. It's very important that we have a personal appearance. The personal touch is very important. When you are physically present in front, it has a different charm. and it has a different environment, and that has a different way of teaching. But here, what happens is, though it's a very good way of teaching online classes. If you see nowadays, slowly by slowly, I think year by year, many of the things will be done online. But here, what happens is, we really need to be focused, very focused. Unlike the classes, sometimes you get distracted here. Here, if you are focused in what we are saying, you can do better. So I do understand that there may be some problems when we teach because of distraction. Something or the other will creep up and then disturb you. Okay, so now let's go further and see the types of fours. Let us see the types of fours. Here, the first one is a symmetrical fold. What is a symmetrical fold? Now these are all taking place because of compression, because of pressure from the two sides toward the center. These are simple folds that are formed when the compressional force applied from the two opposite sides is more or less equal with moderate intensity. That means when pressure from the two sides are applied equally, the land will rise up equally. The land will rise up equally. See, more or less equal? Yes? See, more or less equal? When you apply pressure from two sides equally, when pressure from the two sides are applied equally, the land also will rise up equally. The slope of the land also will be equal. That is called as symmetrical fold, having equal slope. The slopes are equal, gentle. Both sides are gentle. It is called as symmetrical fold. What is an asymmetrical fold? See, when the compressional force applied from both the sides is unequal, it's not equal from both the sides. One is a little bit more and one is less. These folds are called a symmetrical fold. These folds are called a symmetrical fold. This will result to one side having steep slope and the other side having a gentle slope. Like this. The force is more. See? A symmetrical fold. Here it's gentle, but here it's more. So what happens? This side is steeper, and this side is gentle. This is called as a asymmetrical fold. Symmetrical fold means when both the sides are equal, when both the slopes are equal, because the pressure applied is also equal. It's called as symmetrical fold. A symmetrical fold is when the pressure from one side is more compared to the other side. So you can see here the pressure is more compared here. So this is called as asymmetrical fold. Okay, let's go to the next one. Overfold. What is an overfold? This fold is formed when there is extremely unequal force applied from the two sides. Due to the excess force applied from one side, one limb inclines moderately while the other limb inclines steeply. These folds are called more complex. That means here the pressure is more from one side. See this. See? Pressure is gentle, pressure is more. See? This is called overfold. In overfold, when the pressure from one side is gentle, but the other side is very, very high. When the pressure is very high from one side, what happens? It results to that side being very, very steep. That is called as an overfold. These are all taking place because of compressional force, pressing towards the center. Now we have the recumbent force. What is the recumbent force? These folds are formed when compressional forces has excessive pressure, very, very high pressure. In such a case, both the limbs of the fold bend horizontally and are placed over each other, but they do not fold. See here? Like this. Okay. That is, here the pressure is gentle, the pressure is very high, see, excessively high. Continue with this lesson. Now we come to the recumbent fold. Now what is a recumbent fold? Now these are all the folds that are being formed because of the compressional forces. As I told you, when you apply pressure from both the sides, the land in the center rises. So that's how we have the folds being formed. So what is a recumbent fold? These folds are formed when compressional forces have excessive pressure. In such case, both the limbs bend horizontally one over the other. See, like this. Suppose if you apply pressure, it goes like this. Like this, see, pressure this way. Because of excessive pressure, what happens? Excessive pressure. Because of excessive pressure, what happens? One fold goes right in. Because of which, what happens? The limbs of the two folds look as if they are one over the other. See? As if they are one over the other. This is a recumbent fold. When the limbs look as if they are one over the other. But here, there are no breakages. There are no cracks. There are no fractures. This is a recumbent fold. When the pressure from one side is extremely high. Okay, now let's go to the next one. That is the overthrust fold. What is an overthrust fold? Okay, now let's see. Overthrust fold. Now, here, when there is an extremely high pressure or force, the fold is fractured along the axis during the forward thrust. As the rocks cannot resist the force, it represents large-scale tectonic overfold in the crustal rock. In the recumbent fold, the pressure was very high, because of which the rocks or the limbs of the two folds look horizontal, as if they are one over the other, but there was no breakages, no cracks. But here what happens? Because of the excess force, what happens? The limbs crack. The limbs crack and they go one over the other. They rest one over the other. This is called as an overthrust fold. As the rocks cannot resist the force, it represents large-scale tectonic overfold in the crustal plates. This point they break at this point, and otherwise they are like this. No? So what happened now? Because of the excess pressure, what happens? They break and they come down. See? This is the overthrust fold. Because of the excessive high pressure. Now what is the fan fold? In the compression, if the compressional force on the rock strata resembles a wave-like feature, because of the compressional force from both the sides, when the rocks resemble a wave-like feature, it is called as a fan fold. See, like this example. Pressure is here, like this. See, as if they look like a fan, you can see here. This is called as a fan fold. Fan fold, because of the compressional feature on the rocks look like a wave shape, which is called as a fan fold. So these are the types of folds. Now let's see the landform produced by folding. What are the types of landforms that are produced by folding? Different types of landforms are produced by folding, like we have the young Himalayas. The young Himalayas are there, then we have the Rockies, then we have the Andes and the Alps. These are the examples of the landforms produced by folding. That means compression. When the land is compressed, they start to bend. And when they bend, they form into mountains which are called as folding. So we have Himalayas here, Rockies here, Andes here, and Alps. Now let us go further and see what are faults. What is faulting? Now in the case of faulting, I've told you, it's when tensional force takes place. When the rocks move apart from each other, the rocks will slide down, resulting to faulting taking place. Or because sometimes when the rocks are pushed towards each other, and because they are not able to bend, but rather crack and break, again it results to faulting. So what is faulting? See, when the crustal rocks are subjected to tensional or horizontal compressional force, the rock strata instead of folding, bending, that is means instead of bending or folding, they break or fracture at the line of weakness. Whichever part of the rock is very weak, there it breaks instead of folding. The fractures in several layers of the rocks are formed with faulting, which displaces the rock at the breakage or fault plane. The displacement of the rock strata may be upwards or downwards. When the rocks break, they may either rise up or they may either sink down. That is because of folding. See, either they may rise up or they may sink down. I'll just show you this afterwards. Now let's see. Faults are classified according to the direction of the motion along the fault plane. There are four types of fault. Four types of fault are there. Four types of fault. The first one we have is the normal fault. Normal fault. What is a normal fault? When tensional force act from a particular point, pulling the rock strata away from each other in two opposite directions, the rocks are stretched in two opposite directions, forming fractures or a fault. Such type of fault is called as a normal fault. That means when the rocks are pulled apart, when the rocks move apart because of the tensional force, the rocks break and crack, resulting to the land sliding down. The land in the center will move down and slide down. It's called as a normal fault. When the land slide down in the center, like this. See, because the lands are pushed towards opposite direction, the center ones sink, the land center part sinks down. It's called as a normal fault. Now, what is a reverse fault? In some cases, faulting also occurs due to compression. That means when you apply pressure from both the sides, that is called as compression. So, because of compression, also in some cases, faulting takes place. Now, it takes place on the rocks which are very hard, which are not flexible, and which break. Only in those rocks, faulting takes place. In some cases, faulting also occurs due to compression when the rocks are inflexible, see, when they are unable to bend. When the intense compressional force acts from two opposite directions to a particular point, the rocks which are very hard get fractured along the line of weakness. Whichever part is very weak, the rock, they get fractured or they break. That's what I'm saying. A part of the rock strata is pushed against the slope of the fault. That means what happens? In the reverse fault, what happens when compression is applied? When compression is applied, what happens? Here, the land is pushed up. The land is pushed up, see? When compression is applied, what happens? One side of the land is pushed up. The rocks break. Here they break. And then what happens? The land is pushed up after breaking. That is called as reverse fault. Okay, so please keep that in mind. Normal fault and reverse fault. In the case of normal fault, the land is moved down. In the case of reverse fault, the land moves up. Strike slip fault or tear fault. When the two faults slip horizontally along the plane, the rocks move away from each other due to horizontal displacement of the rock strata. This is called as strike slip fault or tear fault. That means sometimes because of the tensional force, what happens when the rocks slide past each other this way, when they move this way horizontally, it's called as strike slip fault or tear fault. And then we have another one, the overthrust fault. Overthrust fault. In such cases, one block of the folded rock strata overrides the other block of rock strata along the fault plane. It is called as a overthrust fault. Like this. See? You can see, no? Overthrust fault. See? This is one block. This may be one block. And you see? Overthrust. In such case, one block of the folded rock strata overrides. It goes on top of the other. To be very more simple, let's be a little bit more simple. Like this. See? Rock strata overrides the other block of rock strata along the fault plane. It is called as an overthrust fault. That means, because of compression, what happens? One rock goes on, stays on top of the other. It rests on top of the other. It breaks, it goes and rests over the other one. So it breaks and goes and rests over it. It is called as an overthrust fault. So these are different ways in which faulting takes place. Examples of faulting, block mountains, like this. Block mountains. Here, block mountains, see? These are block mountains. When the land moves apart, this one will sink down, this one sinks down, this one sinks down, and a block mountain is formed. Because of faulting also we have rift valley. See, when the land moves apart, the land sinks down. See, we have formation of rift valley. Rift valley. So the land sinks down, it's called as rift valley. So block mountains and rift valleys. So these are the two types of faulting that takes place. Block mountains and rift valleys. So I guess this is the end of the chapter, dear students. Please turn your books at the back, page number 85, and do exercise B, C, D, and E. B, C, D, and E. Okay, please do the exercises. Study at home regularly. Minimize the time on mobiles. Help your parents to do the household chores at home. Besides that, if you are still free, read some good books. That will give you a lot of knowledge. I've always told you, if you ever want to be rich in life, read good books. And if you read good books, you will definitely achieve your goals. So till then, take care, dear students. Have a good stay at home, enjoy yourselves, and hope to see you very soon. Thank you so much.